everyone, let's solve this problem. Maximum frequency stack. Design a stack like data structure to push elements to the stack and pop the most frequent element from the stack. So basically, for a stack, if you insert an element and you can only delete the element from the top of the stack. Last in, first out is the principle, but here in this case they're saying whatever is the element which occurs most frequently, we have to delete that. And one more additional case is that if there are like multiple elements with the same number of count and the frequency is same, the maximum frequency, then whichever was last inserted among those frequencies, we have to remove that. Let's try to understand this with an example. So let's say, for example, this is the stack, and we get initially we have initialized stack, then we have 5, so we will insert 5 and we'll also maintain the frequency of them. Then we will insert 7, and then again 5 will increment our frequency, and then 7 will increment our frequency, then 4 will have 1, and then we have 5 will increment the frequency. Now we have a series of pop instructions. Now if we have to pop, we will check the frequency of the elements. 5 has the most frequency, so we will delete 5. We got 5, and then there is one more pop operation. So we have deleted 1 5, so we will update our frequency to 2. Then 7, when we have 7, so basically there is a next pop operation, and 7 and 5 have the same frequency, but the last element was 7, right? From the top of the stack, 7 was the element, so we will pop the 7 and we'll decrement it to 1, and then 5. So if we now when we have a pop operation, if you see at 5 has the frequency of 2, so basically we will remove that and we will pop it, and then again we have one more pop operation. So in this case again we will check all the frequencies are same here, and the top from the stack is 4, so that's the reason we pop it. So this is the same order as the output which we have seen here. So this is not possible, like we cannot pop anywhere, right? I was popping from here, I was popping from here, even though elements were there. So for the general stack operation, that is not possible, so we have to use a different data structure. So let's try and understand what we can do to achieve this particular change. So initially let's maintain a count map, and also we will maintain groups, and also max count. Max count initially will be 0. Count map will be number and count. So initially I get 5, so 5 and its count is 1. In the groups I'll maintain 1 and 5. So this is basically nothing but a map of elements which has in groups. When I have 1, it means it has occurred one time, so that's the reason we have 1 with 5, and then we get 7. So I'll add 7 and 1, and 7 I'll add it to the same frequency because it occurred only once. Then I get 5, I'll increment it to 2. Okay, before this, when we get a group of 1, we will also increment it to 1. Now we got a group of 2, right? Like basically the max count can go to 2. So when I get it 2, I will add it to, this is the frequency and the element which has occurred 2 times, 5, and I'll increment my max count to 2 because I have seen a max count of 2. Then I'll get 7, I'll increment the max count, the count of 7 to 2, and then I'll also add 7 to the groups. Then max count will remain the same. Then I get 4, 1, and 4 occurred only once, so I'll add it to the list. Then I got 5, 5's count will be changing to 3, and then we'll create a new group with 5, and then max count will be changing to 3. So we have iterated over all the elements to push into the stack. Now we will start popping the elements. So at this particular point, when we pop, we will check the max count. Max count is 3, and we will pop the element 5. There is only one occurrence, so we will pop. And if you see, this list will become empty. So when the list will become empty, the max count will also go down by 1. And since we have already popped 5, we will decrement it to 2. And then again we have a pop operation. So when we have a pop operation, we'll check the max count. In the max count, we will remove the 7. There is one more element, so we are not going to decrement the max count, but we will be decrementing the 7th count to 1. And then there is one more pop operation. Max count is 2. We go to the groups and check. There is a 5, so we pop it, and we also decrement its count. And then again we have a pop operation. What do we do? And before this, this list has become empty, so we are going to change our max count. Now we have one more pop operation, and in this operation we have the max count as n. We will go to the groups 1 and we find the element 4. 4 can be popped, and this is the order, and for 4 it will become 0. So these are the elements which we need to print. This is how it works. And the reason why we are going to maintain a list here is that in order to know the order of elements, in which order it has been pushed, right? That if we know, like let's say for example, if I push 1 2 3, I know that I should be popping from 3 to 1 when the count of these elements are same. That is the only reason. Now let's try to write code for this. We'll maintain a count map. We also will maintain the groups. We'll have a max count. Then inside push current count. If there is no element, it will be initialized to 1. So I am just directly giving it as 1, and we will check if count map has this element. If yes, we will get the current count from count map dot get value plus 1. And then once I get the current map, I also have to set the value with the current count. So far we have just checked if the element is present in the count map or not. If it is not present, we are initializing it to 1. If it is present, we are incrementing the count of it. This is the count map which we are talking about. After that, I will check if current count is greater than max count. If this is the case, I'll update my max count with my current count, and then I will, inside the groups, I'll create a current count comma array, and after that I'm going to append current count, get the current count array, and then push the value. So this entire thing is nothing but, let's say for example, I got initially 5 and 1, right? There will be max count of 0. I will be incrementing max count to 1, and if there is no 1 in the groups, I'll create 1 with an empty array and then push the value 5 into that array. That is the step which we are doing here. If it is already present, we will not go into this. If the group is already present, we will never go into this, because the max count will already be present and current count will be less than or equal to the max count. So that should be good. Then for the pop, we will get the frequent element. This will be coming from groups dot get of max count dot pop. Will get the last element, and then once we got the last element, we will first from the count map we will set the element which we just popped with. We will get the count of this particular element. We will decrement it by 1 and we'll set it, and then we also will check if groups dot get of max count dot length is equal to 0. It's nothing but if I have just popped 5 from this particular example, then the list is empty. That means there are no more elements which are having frequency of 3. That means I have to reduce my max count. So my max count will be reduced, and then we will have to return the element from the whichever we have popped. Let's try to run this. Let's try to submit this. It's successful. And also let's understand the time and space complexity of this. For a push operation, we are checking if the element is present and getting this is big O of 1 operation. We are setting this is big O of 1 operation. Again we are just doing a if check. This is 1 operation. This also is 1 operation. This is also 1 operation. So entire push will take big O of 1 time. Similarly for pop, we are getting and setting few elements here, so it will also take big O of 1 operation. So the time complexity of both the solution is big O of 1, and the space complexity for this solution is big O of n. Basically we have count map and groups, but overall n plus n it will be there, so it will be big O of n. Even though if we also consider like for map key value, it will be like n plus n, and then for groups there will be n elements, and at max there can be like n frequencies, so it will be n plus n again, but overall it will be big O of n. I hope the solution is clear. Thank you.